Good morning, everyone. Am I audible? Am I audible to you? My voice is audible to you? Okay. So, okay. So in last class, what did you study? What did we study? Do you remember? In last class, what did you study? And first of all, tell me how is your exam? How is your exam? Is it good? I think all of you have got out of 30, 28, 30, most of you already got 30, and some of you have scored 25, 28, isn't it? The lowest marks, I think the lowest one is 16. Okay, so I think it is good, isn't it? Okay, so in last class, what did you study? We studied about. Okay, let me share content. Okay, just wait a minute. In last class, we have discussed about gradually varied flow, isn't it? Okay, so let me share my screen. Oh, I don't know what is happening. Okay, let me share some my screen. Okay. Uh, we are discussing about CBF, isn't it? CBF. So let me share. Just wait a minute. Done. Also, okay. So my screen is visible to you. My screen is visible.
Yes, ma'am.
My screen is visible to you? I can't hear what happened. Okay.
Yes, ma'am. Yes, ma'am.
Yes, you tell me my screen is visible or not? Yes, okay. So, in last class, we have discussed ZVF, isn't it? ZVF. So we have already discussed what are the different types of ZVF, isn't it? What are the different profiles of ZVF, isn't it? So these are the profiles. These are the profiles of ZVF and RVF. Sorry, these are the slope, okay? And mild slopes, steep slope, critical slope, horizontal bend, and adverse slope. And the short form of the slope is M slope, S slope, C slope, HA. Okay. And what are the conditions? For mild slope, normal depth is greater than critical depth. For steep slope, YC is greater than Y naught. And for critical slope, generally this tree slope is mostly common. And when YC equal to Y naught, then the slope is C slope. When when bed slope is 0, that means there is no slope, then the symbol of profile is H profile. And if there is a negative slope, then that exists a adverse slope. Okay. So let me show the, yes, these are the conditions of different profiles. We have discussed these things already. Let me revise once again. So now this is the mild slope. Okay. Here the bed slope is positive. This is steep slope. Again bed slope is positive. And in mild slope, CDL is below the NDL. What is CDL? Critical depth line. Critical depth line means the line joining the critical depth. That is called critical depth line. Okay. And this is the NDL. Okay. What is NDL? Normal depth line. So this is the condition of M slope. This is the condition of steep slope. And this is critical slope, horizontal slope, and adverse slope. In case of adverse slope, the slope is negative. Can you see? See, in horizontal slope, this is the flat slope. That means there is no bed slope. So S is 0. But in case of adverse slope, the slope is negative. Okay. And there exists only C, critical depth line. There is no NDL in case of adverse slope. Okay. This is the conditions of S profiles, and this is the various condition of S profile. Again, the profiles can be classified as M1 type, M2 type, M3 type. The mild slope can be classified as M1, M2, M3. And steep slope can be classified as S1, S2, S3. Okay? And in case of critical slope, there is only C1 and C3 slope. Okay? So remember these conditions. And horizontal bed, for horizontal bed, there is H2 and H3 profile. Okay. And adverse slope, again only A2 and H3. These three conditions, all these conditions you remember. Yes, one numerical is there. I think already I have discussed this numerical, isn't it? So I will not discuss today this numerical. Yes, M profiles. This is the figure of M profile. This is the situation where M1 profile exists. This is the situation of M2 profile in case of M profile, okay? And this is the situation of M3 profile. For M1 curve, the most common of all ZBA profile is the M1 type, okay? Which is a subcritical flow condition. Obstructions to flow such as weirs, dams, control structures, natural fissures or bends produce M1 backwater curve. These extend to several kilometers upstream before merging with the normal depth. This is the M2 profile. When M2 profile exists, when there is a sudden drop of the channel, okay? When there is a sudden drop of the channel, then M2 profile exists. Let me do one thing. Yes, can you see the screen now? Okay, so this is the condition of M1 profile and M3 curve. This is the M2 type. This is the M3 type. When M3 occurs, suppose in exam you are asked to identify some profiles. The figure is given and you have to identify the profiles. Then what you will do? You have to check the NDL critical line, NDL CDL, okay? And when M3 profile exists, when there is a sluice gate and it resists the flow then M3 profile exists, okay? And S curve. This is the condition of S curve. The S1 profile is produced when the flow from a steep channel is terminated by deep pull. Deep pull created by an obstruction, such as a dam. Okay? At the beginning of the curve, the flow changes from the normal depth to subcritical flow through a hydraulic jump. The profile in the downstream with a positive water slope is reach a horizontal asymptote at the pool elevation. That means when a flow is going from a lower depth to a higher, that means if it is passes through a dam or weir, then S1 profile exists. Okay? When flow is, that means the flow is overflowing through a dam, then the profile is called S1 profile. Steep slope profile. S means steep slope, isn't it? And the condition is NDL is below the critical depth line. And this one condition is there, jump is created. See, I will discuss about jump in RVF chapter. Okay, I will discuss about what is hydraulic jump. I will discuss in next chapter. Okay, next chapter, that is your RVF, rapidly varied flow. This is the condition of S2 profile. Profiles of S2 type occurs at the entrance region of a steep slope leading from a reservoir. Suppose it is flowing from a steep slope to a lower slope than S2 profile exists. Okay, this is the condition of CDL, and this, that means the CDL is above the NDL. The critical depth line is always above the normal depth line. Water surface will be in region 2. That means this is a YC, this is the curve of S2 profile. Water surface will be in region 2 for a steep slope channel, and the flow is supercritical. Supercritical with critical depth is greater than normal. Depth of flow is greater than normal depth. Okay, and Froude number is greater than 1. This is the condition dy by dx equal to, this is the slope, isn't it? Change in depth along x direction. Dy by dx equal to S0 minus SC divided by 1 minus FR square. I have already discussed how we got this formula in previous class. Okay. So water depth will decrease in the flow direction. Next, S3 profile. S3 curve results when free flow from a sluice gate with a steep slope on its downstream, or a flow exists from a steeper slope to a less steep slope. Okay, this is the NDL and this is the CDL. CDL condition. CDL is above the NDL, and this is the S3 profile exists. Water surface will be in region 3 for a steep slope channel, and the flow is supercritical. This is the C curve, critical slope. General shapes of C curves are showing here. This is the C1 profile and C2 profile. There is no C2 profile, only C1 and C3 profile is there. Okay. And C profile, this is the figure of C profile. C1 and C3 profile are very rare and highly unstable. So this generally is critical slope profile is unstable and it is very rare. Next, H profile, horizontal profile. In horizontal profile, there is no H1, only H2 and H3 profile exist. Okay. So general shapes of H curves are given in figure for horizontal slope channels. Uniform flow depth, why not, does not exist. Here, uniform flow depth, why not exist. Critical water depth can be computed for a given discharge Q, and therefore critical water depth line can be drawn. Since there is no uniform water depth, why not? Region 1 does not exist. Okay, there is no region 1, only H2 and H3 profile. A control section is defined as a section in which a fixed relationship exists between discharge and depth of flow. For example, wheels, spillways, sluice gates are some typical examples of structure which gives rise to control section. So these are the control sections. Okay, spillways, sluice gate, wheels. These are these structure generally called critical sections. The critical depth is also a control point. However, it is effective in a flow profile which changes from subcritical to supercritical. In the reverse case of transition from supercritical flow to a subcritical flow, a hydraulic jump is usually formed by passing the critical depth as a control point. Any gradually varied profile have at least one control section. So this is very important point. Any type of gradually varied flow profile will have only at least one control section. Okay. Analysis of flow profile. Okay. So how can I analyze the flow profile? A channel carrying a gradually varied flow can in general contain different prismoidal channel cross-section varying hydraulic properties. There can be a number of control section at various locations. To determine the resulting water surface profile in a given case, one should be in position to analyze the effects of various channels and control connected in series. Break in grades. Some situations of a series combination of two channel section. Suppose generally if you combine two critical sections, then it is behave like a combination of control section. Okay. Computation of gradually varied flow. So how can we compute the gradually varied flow? The major activities of hydraulic engineers in free surface flow involve the computation of ZVF profile. Number one, determination of the effect of hydraulic structure on the flow parameters, of the flow pattern, and inundation of lands due to a dam or reconstruction, and estimation of flood zone. Historically, it is a topic for last 150 years. The various available procedure for computing ZVF profile can be classified as direct integration, mainly used for academic interest. Okay. So direct integration, number 2 is numerical method, number 3 is graphical method. Okay. So these are the three different procedure available to compute ZVF profile. One is direct integration method, next is numerical method, and next is graphical method. Okay. So what is direct integration method? As we know, the basic differential equation of gradually varied flow is, what is the basic difference equation of gradually varied flow? dy by dx equal to S naught minus SC divided by 1 minus alpha Q square T divided by ZA cube. Also, we can write as Frod's number. Okay, F4 square. Next, if K convenes of any depth Y and K naught is the convenes to the normal depth Y naught, then K equal to Q divided by root over SF. And cannot equal and K not equal to K divided by root over S naught. Okay. So generally direct integration method. The details methods are not required. Direct step method procedure. Okay. Competition of ZVF is given as a very regular manner. Numerical analysis, simple method, simple numerical method, direct step method, standard step method, advanced numerical method. So, okay. So, I will discuss about different methods in the next class. Okay. Let me stop sharing. Okay. View on. Roll number 45 and 9. What happened to them? It is showing that two participants are waiting in the lobby. Sila and Sotu. Uh, I think you can, something happened. I have not seen this type of problem. How many students are there? Participants. Let me note down your roll numbers. Roll number 19, 3, 44, 40, Long Kumar, 2. Roll number 45, Heketo Achumi. Heketo Achumi, you should write your roll number, okay? Write your roll number and Whenever you join, you write down your roll number by your name. 30. Okay. Roll number 8, 33, 4, 9, 7. Okay. Yes, I have got. One, two, three, four. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26. 26 student present. 26, 27, 28, 29, 30. 30 student present. Okay. I think you can leave. Next class we will discuss. Okay. Thank you.